Hello React Native developers, I hope you are well. William here, recording from beautiful Zurich, Switzerland. In this video, I would like to cover 4 novelties part of the latest Expo SDK release, version 44, namely the layout animations, part of the reanimated 2.3 version, the new composable gestures from Gesture Handler, and the experimental support for animation worklets in the OpenGL view, as well as the preview of Expo Application Services update. Thank you to Expo for sponsoring this video. There are definitely a couple of noteworthy items part of this release, mainly the updated library suite from Software Mention, layout animations part of Reanimated 2.3, the new composable gestures part of Gesture Handler version 2.0, and React Freeze part of React Native Screens version 3.1. Before we dive in, I invite you to check out the blog announcement from the Expo team. It does mention some interesting changes, such as the React 17 JSX transform now being enabled by default, so you don't need to have the default React import in your components, and the Expo System UI and Expo Navigation Bar modules that can now be used directly with the Expo Go client. Now let's have a look at layout animations, part of Reanimated version 2.3. Layout animations are the easiest way to animate things in React Native. So far in Reanimated 2, the way we were animating things was quite static. We had a non-position of an element with an XY value. We were animating it to another XY position, and these animations were triggered either in a use effect hook, so listening to a side effect in the application, or either by a gesture in the use animated gesture handler, or by listening to a change in an animation value in a use animated reaction. Now, layout animations are quite different. They can be triggered automatically by when a component mounts, unmounts, or when its flexbox layout changes. The documentation is pretty comprehensive. You have tons of built-in animations when a new component is mounted, unmounted, or when its flexbox layout changes. On top of that, you have a lower level API that gives you full control over the layout animations in case you want to build a custom animation that perfectly matches your need. Now I would like to show you 2 examples of the new layout animation feature, and the first one is the most classical example when talking about layout animations. It's a list example. It's a most classical example because here the items are displayed dynamically using the flexbox layout, and usually you're going to have a lot of state changes in your list, and these are changes of React state. And so here I can, for instance, press the cross icon to remove, so to change the state of the list. And now we would like to animate things nicely. So you see here my list of recipes. If I go in the receipt component, what I would like to do now is to wrap it into an animated view. And I mentioned that layout animations work on mounting, unmounting the component, and when the layout changes. And so we have 3 properties for that. We have entering, exiting, so for when mounting, unmounting, and layout for when the layout changes. So let's start with when entering, so when mounting the component. So I can do entering, and we can use one of the built-in animation. So maybe we can do a zoom in, zoom out, no, zoom in, or maybe a fade in. And so you have, the naming is pretty consistent. Fade is the type of animation. In or out, so is it an exiting, entering, or exiting animation? And then the direction can be up, down, left, right. So here, fade in, up. I mean, I have no idea. Let's try it. I didn't save the file, I think. Looks good. It felt a bit static because they were all moving at once, so maybe zoom in. Zoom in. Let's have a look. Okay, I mean, I don't know. I guess it's a matter of taste. I will let you pick default animation that works well. But now, of course, if I want to exit by pressing the cross, I want the element to disappear nicely. So I can use exiting. And here I can use the built-in zoom out animation. So let's have a look. So it zooms in and it zooms out, and it does look super weird because the layout is not animated, and so the exiting is being animated while everything else is being done statically. So we're going to add a layout animation. And I think the default animation is going to be layout. So let's have a look. So here it animates nicely. And the only thing I would like to change is to add some delay to the layout so that it doesn't overlap the exiting animation. So here maybe I can add a delay of 200 milliseconds. So it zooms in, and you see the delay is pretty nice. So it adds really, it exits and then makes the layout. So very cool effects. There are two things which I really love about this. The first is that it was extremely easy to, you see it was only like 3 lines of code to add animation to a default user experience. And they provide a lower level API in case we want to build really tailor-made animations to a particular user experience. But the second thing which I really love about these higher level animation constructs is that you can start incrementally with your user experience. So first we had the list and the functionality of removing items from the list fully working, and then we could add some effects to the user experience without modifying it. And this is a bit new from previous reanimated Chew animations that we explored, where often with the gesture handler and the reanimated, we had to build a user experience which by default was needed to be working with reanimated Chew. Here we can build a user experience without animations and go step by step, which I think is pretty nice. It's also something you find in other, I think, higher level animation libraries, such for instance as React Native shared transitions. So I think this is pretty cool. And now I would like to show you a second example, which is this collapsible item list. And we used to animate it with reanimated Chew. It was extremely complex, so we used to have a animation value to know if it's open or not. And we used to use reanimated Chew to measure on the UI thread the size, the dynamic size of the items. And then to know to the height, we needed to animate the elements. And so, yeah, that was pretty complicated. And again, it was not like a it was a user experience which was built in reanimated Chew, not something we could start incrementally. So here it kind of works already. It's just that the UX could be dramatically improved, but it kind of works already. Whereas sometimes when building animations with reanimated Chew, we don't really start from reanimated Chew first. So let's try to use layout animations to improve the user experience. And so we have the list here that is mounted if the state is open, which is a React state. So we're going to wrap it into an animated view. And when the component mounts, so entering, we do a fade in, and direction, let's do up. And so if we do this, when exiting, it should be a fade out up. That actually works great. Of course, same issue than for the previous example. When the layout changes, so the position of the headers and the content, we need also to animate. So we have the header here. So again, we're going to wrap it into an animated view. And so we're going to animate the layout and use the default layout animation. And we need to do the same for the content in case the list is collapsed. So let's have a look. It feels really, really good actually. And it's not even, it's not even pixel perfect, but I think you see in like a few seconds, 4 lines of code, we dramatically improve the user experience. And then if you want, you can dig further and build your own custom animation to really build maybe animate on the height and build the proper effect. This was a brief intro into the layout animations part of Reanimated 2.3. I think you're gonna love it. And now let's talk about the new composable gestures part of Gesture Handler version 2. This new version is completely backward compatible with previous versions, so you can safely upgrade to Gesture Handler version 2.0. The biggest change in this new version is the gesture detector component. It used to be that we would have a pan gesture handler, a pinch gesture handler, and so on, and sometimes we had to deal with compositions on these gesture handlers, and it used to be quite hairy. Now we have a single component gesture detector that can detect any kind of gesture, and you can assign the appropriate gesture handlers to that gesture detector. Now this is really interesting when composing with different gesture detections. For instance, a pinch, a rotate, or a pan gesture handler. And we have operators to compose between these gesture handlers. Simultaneous, all of the gesture can become active at the same time. Race, the first gesture that becomes active cancels other gestures. Exclusive, the first gesture can become active at any time. The second gesture can activate only when the first gesture fails, and so on. Let's have a look at a simple example. So I have a black circle here, which maybe I want to be able to pinch and pan around. And so instead of having a pinch gesture handler and a pan gesture handler, we're going to use one gesture detector and use some composition on these gesture handlers. So we wrap our view into a gesture detector, and we have the gesture property. So we're going to write a pan gesture handler. So we're going to do gesture.pan and pinch, and then our gesture. And here we're going to use the race operator, so the first gesture that activates cancels the other gesture detections. So gesture equals gesture.race. And we can pass pan and pinch. Now let's add some gesture handling. So here you see there is a new API style. We can use some chaining. It is completely identical to previous gesture handler. So to migrate from the old API style to the new API style, I think is pretty straightforward. So here it would be on change, and we get the same event parameters as always. So for instance, here it would be translation X and translation Y. And so we can update the animation values. Yeah, exactly like this. And on pinch, we're going to get the scale value. So on change, we get the event. And so we can do scale.value equals event.scale. And so we have the appropriate animated style here already. So let's have a look. So here I can zoom in by pitching and move the ball around. So really a fun, I mean, this here implementation is super simple, but I think it shows the power of composable gestures and how easily now we could go deeper with such an example, where previously I think these combinations of gestures used to be extremely complicated. There are some other noteworthy features part of this new gesture handler release, namely the deeper integration with Reanimated 2 and a new gesture, manual gestures, that can allow you to build any kind of custom gesture detections. So you get the raw events from the view and you can use it to build some custom gesture handling. We use an identical API in React Native Skia to build custom drawing features such as this one. Now, let's talk about a new feature that is highly experimental, but that I'm just really excited about, and that is support for animation worklets in the OpenGL view. Reanimated 2 is excellent to animate properties of native views, but when having an imperative API, in the case of the OpenGL view, for instance, the story on how to animate such a view was not clear. And now there is an experimental support for animation worklets where you can access the GL context from the UI thread. So you can animate it directly in the UI thread. And I would like to show you an example. So I have this simple 2D shader here. So I have the vertex shader, which is a copy-paste from the default shader from OpenGL React, and the fragment shader. So we simply interpolate the color based on the position of the pixel. And here I have a blue component value that goes from 0 to 1. Here it's a uniform, so that's the value I would like to animate. I think here its default value must be 0. Where is it set? So we set it to 0 indeed. So that's what we would like to animate. So we have all the WebGL setup and the GL view with the OnGL create. So now we can access the GL object from the UI thread. So we could use it to update the uniform value. So I'm going to create, so to access the ID of the GL context, I'm going to store it into a shared value. Maybe I can call it context ID. And default value is 0, which I think incidentally is also probably the default ID of the GL view, but let's say of course we don't know the ID of the object. So when we create the context, I can assign it. So I can do context ID.value equals GL. I think it's called context ID. And now that we have the ID available in the UI thread, we can use it for animations. So first, I'm going to create an animation. So let's call maybe a progress animation value, and I'm going to assign the loop animation. So use effect, maybe like a loop. So value equals with repeat of with timing. So we go from 0 to 1. 1 second sounds good. Infinite, and we want the boomerang effect. So now we have our animation value. And what I would like to do is to trigger a worklet function when the value changes. So I'm going to use a use animated reaction, which might not be the best way to animate. And this is where I think the support might be completely experimental, because that might not be the fastest way to animate such a WebGL view. In fact, in the example they give in the documentation, they use a gesture, so that drives directly the animation. But then, let's say when the gesture ends, you still want to animate like a decay or something like this. How to schedule these animations, I think, is not clear yet. But here, every time the progress value changes, I'm going to call it, I don't know, update uniform. And we can pass the progress. So value is the progress, and we can also pass the context ID. So let's create this worklet function. So we get the progress and the context ID, which is also a number. So this is a worklet. that runs on the UI thread. And here, so no, I was about to say Copilot is correct, but it doesn't seem to be correct. So it's get worklet context. Given the context ID, gives us the GL context. So if the GL context is available, now we can update the uniform. So we need, again, Copilot is kind of right in this suggestion. So we need to clear the view, update the uniform, draw the draw, flush, and I think that we should be good. So let's clear first. Yeah, I think I have it here. So we clear and we flush. That's good. We need to update the uniform. So here, so Copilot is kind of right, but you see I don't have access to this to the program variable, and I'm not sure how to access this program variable from the UI thread. Again, I think these things are still pretty experimental. We're trying to figure it out. But I can use a hack. I know that's the first uniform, so its ID is going to be 0. And so passing this object is going to be enough to identify the uniform, progress, so I have the right value. And now I need to do the drawing. So I'm going to do draw arrays here. And this should be enough to animate. So it seems to animate nicely. Here the load on the UI thread is pretty high, maybe because I'm doing something wrong in terms of how to schedule the animations. But I think we're really trying to figure out how to animate these GSI modules. I'm really glad that we're getting into these topics. Here it's a 2D shader because that's the only kinds of shaders I know how to do. And of course, if you want to animate a 2D shader such as this one, I strongly recommend you use React Native Skia. You will get order of magnitude better performance. But here I think it starts a discussion. It opens a lot of possibilities on maybe building like thin layers for libraries such as Free.js, and there are other JavaScript 3D libraries. So I'm super excited about the topic, and I'm super excited that we start to have these conversations about animating things like GSI modules and imperative APIs. Now, last feature I would like to cover, part of SDK version 44, is a preview of Expo Application Services update. Expo Application Services updates is a service that allows you to manage over-the-air updates on your apps and now supports new kinds of workflows. This service is in preview mode, meaning that currently to use it, you need to be using the paying tier of EAS. A React Native app contains a native layer and a JavaScript layer, and the app can be distributed on any kind of channel. App Store, Test Flight, Play Store, direct download, you name it. Now, the JavaScript layer can be updated over the air, meaning that you can update the app without changing the app binary. Exactly how you would update a web app. By default, updates work the following way. When opening the app, a new version of the app manifest is downloaded to see if a new version of the JavaScript bundle exists. And if it does, it gets downloaded. And if they are missing assets, they get downloaded as well. If the operation is done in less than the duration specified by fallback to cache timeout, you get the updated version of the app. If not, you will get the updated version of the app the next time the app opens. Alternatively, you can configure the update workflow manually. Again, very similar to the way a web app would update. Now, in Expo Application Services, you can have different distribution channels. For instance, a production channel for the app and Play Store, and a staging channel for Test Flight. Note that the runtime version is important here, as it expresses the version of the native API that your JavaScript code can rely on. A channel is linked to a branch which contains the updates that will be published over time, and you can change the branch a channel points to. Here, Expo is creating symmetry with how Git and GitHub workflows would look like. In previous videos about Expo SDK releases, we talked about Expo development clients, which are really improving the development experience of building a React Native app by decoupling completely the native development lifecycle from the JavaScript development lifecycle. And now with ES updates, we can easily manage the over-the-air updates of the JavaScript code. Again, if we were to continue the analogy with web apps and gaining web development like agility when building React Native apps, your custom native code with the Expo development client is a bit like shipping easily a custom browser you can use. So you can use native APIs within your web app. And using EAS updates, you can easily ship and manage the versions of the web app you are distributing to your different clients, which are using also different versions of the native code. That's it for me. I hope that you enjoyed this overview of Expo SDK version 44. Thank you to Expo for sponsoring this video. I am looking forward to talk to you soon. And until next time, happy hacking.